What is the role of an AI architect? An AI architect is responsible for designing, implementing, and overseeing AI and machine learning solutions within an organization. This includes understanding business requirements, selecting appropriate AI technologies, designing scalable architectures, and ensuring that AI solutions are integrated seamlessly into existing systems. They also focus on data governance, security, and compliance, and often collaborate with data scientists, engineers, and other stakeholders to ensure successful deployment of AI projects. Can you explain the difference between AI, machine learning, and deep learning? AI, artificial intelligence, the broad field of creating machines that can perform tasks that typically require human intelligence, such as reasoning, learning, and problem solving. Machine learning (ML), a subset of AI that involves training algorithms on data to make predictions or decisions without being explicitly programmed for each task. Deep learning (DL), a subset of ML that uses neural networks with many layers, deep networks, to model complex patterns in large data sets. How do you approach designing an AI solution? Designing an AI solution involves several key steps. Requirement analysis, understanding the business problem, goals, and constraints. Data collection and preparation, gathering relevant data, cleaning, and pre-processing it. Model selection, choosing appropriate algorithms and models based on the problem. Architecture design, designing the system architecture, including data pipelines, model training, and deployment infrastructure. Training and validation, training models on the data and validating their performance. Deployment, integrating the model into the production environment. Monitoring and maintenance, continuously monitoring model performance and updating it as needed. What are some common challenges in deploying AI models in production? Common challenges include data quality and availability, ensuring high-quality relevant data is available for training and inference. Scalability, designing solutions that can scale with increasing data and user load. Model drift, addressing changes in data patterns over time that can affect model performance. Integration, seamlessly integrating AI models with existing systems and workflows. Compliance and security, ensuring data privacy, security, and regulatory compliance. Monitoring, implementing robust monitoring to detect issues in real time. How do you ensure the ethical use of AI in your solutions? Ensuring the ethical use of AI involves bias mitigation, identifying and reducing biases in data and models. Transparency, providing explanations for AI decisions and maintaining transparency in AI processes. Fairness, ensuring AI systems treat all users fairly and do not discriminate. Accountability, establishing clear accountability for AI decisions and actions. Compliance, adhering to legal and regulatory standards related to data privacy and AI usage. What is a neural network and how does it work? A neural network is a computational model inspired by the human brain, consisting of interconnected nodes, neurons, organized in layers. Each neuron receives input, processes it using a weighted sum, applies an activation function, and passes the output to the next layer. The network is trained by adjusting the weights based on the error of the output compared to the expected result, typically using a method called backpropagation. Neural networks are capable of learning complex patterns and are used in deep learning for tasks such as image recognition and natural language processing. Explain the concept of overfitting and how you can prevent it. Overfitting occurs when a model learns the training data too well, including its noise and outliers, resulting in poor generalization to new, unseen data. To prevent overfitting, use more training data. More data helps the model learn general patterns. Cross-validation. Use techniques like k-fold cross-validation to ensure the model performs well on different subsets of data. Regularization. Apply techniques like L1 or L2 regularization to penalize large weights. Simpler models. Use simpler models with fewer parameters to reduce complexity. Dropout. In neural networks, use dropout layers to randomly deactivate neurons during training. What are some popular libraries and frameworks for AI and machine learning? Popular libraries and frameworks include TensorFlow, an open-source library for machine learning and deep learning by Google. PyTorch, an open-source deep learning framework by Facebook. Scikit-learn, a library for classical machine learning algorithms in Python. Keras, a high-level neural networks API, often used with TensorFlow. OpenCV, a library for computer vision applications. NLK and SPACY, libraries for natural language processing. How do you handle imbalanced datasets? Handling imbalanced datasets involves resampling, oversampling the minority class or undersampling the majority class. Synthetic data generation, using techniques like SMOTE, synthetic minority oversampling technique to create synthetic samples for the minority class. Cost-sensitive learning, modifying the learning algorithm to penalize misclassifications of the minority class more heavily. Anomaly detection methods, treating the minority class as anomalies and using anomaly detection techniques. Describe a time when you had to debug a complex AI model. What was the issue and how did you resolve it? I once worked on a fraud detection model that was underperforming in production. The issue was that the model's accuracy dropped significantly compared to the training phase. After thorough debugging, I discovered data leakage where future information was unintentionally included during training. I resolved it by ensuring proper data partitioning and strict separation of training and validation datasets. Additionally, I implemented cross-validation and retrained the model, which improved its generalization and performance in production.